In this video, we talk about a series, and in the some of the upcoming lessons, we will continue the discussion of series. So today, we just introduced the concept of a series that you are probably familiar with from the more elementary courses. But here, our emphasis will be on the infinite series, the series which have infinitely many terms. And also today we talk about one type of series that, again, you might have seen in more elementary courses, but we'll discuss that from the infinite series point of view. So let's see how a series is formed. Suppose we have a sequence. We talked about sequence before. Suppose we have a sequence AN, uh, be a sequence. This n can start from any integer. Let's here assume it starts from 1. So n runs from 1 to, the index runs from 1 to infinity, and we have a sequence. Let's call S1 just be the first term. S2 is the sum of the first two terms. S3 is the sum of the first three terms. Or in general, Sn is the sum of the first n terms, a1 plus a2 plus a3 up to an. And S stands for sum, so Sn means the sum of the first n terms of the sequence. All of these are called partial sums. The phrase that is used to refer to these sums is they're called partial sums. So there is a question here, and the question is, if n tends to infinity, does Sn converge to a finite number or not? So the main question about series, about infinite series, is the main question. Does Sn, which means the sum of the first n terms, a1, a2, a3 up to an, converge to a finite number as n tends to infinity? So it depends on the given sum. It depends on what are an's. So when we add them up, does that the sum tend to infinity or not? Okay, so one more time, let me repeat what Sn is the sum of a1 plus a2 plus a3 up to an, And if we let n to infinity, that's continuing. It doesn't stop anywhere. So let me just make it a1 plus a2 plus a3 and then dot 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 after that, meaning that it doesn't stop. And so I can put the limit sign here. So the limit of Sn as n tends to infinity is the sum of all of these infinitely many numbers. There are infinitely many of them, a1, a2, a3, a4, and so on and so forth. But it doesn't mean the sum is infinity. Sometimes the sum is a number. Sometimes the sum is infinity or minus infinity, or even sometimes the sum is not any specific thing. First of all, the notation that we use, that probably in more elementary courses you have seen that notation, is the sigma notation. So instead of using Sn or a1 plus a2 plus a3 plus dot dot dot, we use this notation, the sigma notation of a n or a k. Let me go with k, and k runs from 1 to infinity. So this is the notation that we use for limit of Sn as n tends to infinity, or a1 plus a2 plus a3 plus a4 plus a5 plus we just go on forever. And this is what's so-called an infinite series. So when I write this sigma notation, sigma of ak, k runs from 1 to infinity, I don't need the limit sign anymore. Inside it has the limit concept. As you know, there is nothing special about using the letter A or K. So this, if I use, say, sigma of B M, and M runs from 1 to infinity, this simply means B1 plus B2 plus B3 plus dot dot dot. We keep adding up B with different index. Okay, let's see some examples of series or infinite series. For example, sigma of 1 over n runs from 1 to infinity. What is this series? If I want to expand, if I want to write down some of the terms of that, when n is 1, 1 over 1 is 1 plus. When n is 2, then I have 1 over 2 plus. When n is 3, I have 1 over 3, and so on and so forth. Now the question is this sum a finite number or not? We get there later, not in this video, but in one of the next videos, we'll talk about this, whether it is this sum is a number, a finite number or not. By the way, this series that we'll see again in this course has a specific name. It is called the harmonic series. Let me, this is called the, just let me mention it inside this parenthesis. This is called the harmonic series. One of the things that we do later, not in this video, is to determine whether this series is a number, a finite number or not? The harmonic series doesn't need to start from one, like sigma, if I write the sigma of 1 over n, and n rounds, say, from 5 up to infinity. What does that mean? It means that I start from 5. So when n is 5, I have 1/5. When n is 6, it's 1 over 6. When n is 7, 1 over 7, and dot, dot, dot. Let's see another example. Sigma of 1 over 2 to the power of k. K runs from 0 to infinity. Let me expand this and write down, let's say, for the first four terms. When k is 0, 1 over 2 to the power of 0. 2 to the power of 0 is 1, and 1 over 1 is 1. So the first term is 1. When k is 1, here notice that k starts from 0. That's why for the first term of this sum, I use k equals 0. When k is 1, 1 over 2 to the power of 1, just 1 half. When k is 2, 1 over 2 squared, 1/4. When k is 3, 1 over 2 cubed, 1 over 8, and so on and so forth. Uh, you might have seen this in more elementary courses like pre-calculus or even college algebra. Do you remember what this series belonged to, which class of series? Here, to obtain the next term, we just multiply the previous term by a fixed number. There's a common ratio involved. This is an example of a geometric series. This is an example of a geometric series. There is a common ratio that is multiplied by every term that gives us the next term. Of course, if you have seen this in more elementary courses, at that time there was no, the focus was not on the limit of these kind of things. It was a finite series. Just you have seen the sum of a finitely many terms of this series, not infinitely many of them. But here in this course, we talk about infinite series, so there are infinitely many terms involved. So here for this geometric series, the common ratio is 1/2. So the common ratio is 1/2. Like one, look at the first term is 1. From 1 to 1/2, I multiply by 1/2 to get there. From 1/2 to 1/4, I multiply by 1/2 again. From 1/4 to 1 over 8, there is a common ratio. The previous series, the harmonic series, is not a geometric series. There is no common ratio. But here, there is a common ratio. Of course, most series are not geometric series, but since the first type of series that we'll discuss today will be geometric because you have some knowledge about that from more elementary courses. But that's why today we'll talk more about geometric series and determine which geometric series become equal to a number, which one don't. Let's see another example. Suppose I have a sigma of 3 to the power of k, and k runs from 1 to infinity. Let's write the first four terms. Here k starts from 1. So when k is 1, I have 3 to the power of 1, which is 3. When k is 2, 3 squared, 9. So 3 plus 9. And then when k is 3, it is 3 cubed, which is 27. When k is 4, it is 81, and so on and so forth. This is also a geometric series. This is an example of a geometric series. What is the common ratio? Common ratio is 3, right? 3 is multiplied by every term to give me the next term. So the common ratio is 3. So before talking more about the geometric series, let me, and as I mentioned, most series are not geometric series, but in the discussion that we have today, we'll focus on geometric series. In the upcoming lessons later, we talk about other series. But let me make the definition, which is for all the kinds of series. In fact, this is to introduce a phrase that is a very important thing. An infinite series is convergent or is called convergent if it equals a finite number. Otherwise, it's divergent. So as I mentioned, today we talk about the geometric series, and we want to know that when a geometric series is convergent and when they are divergent. First of all, let me write down the expanded form of a geometric series. As you know, there is a first term. Suppose I call the first term just A. And there is a common ratio that is multiplied by the first term to give me the second term. And the same common ratio is multiplied by the second term to give me the third term. And so on and so forth. So here, A is the first term, and R is the common ratio. So that's the common ratio is multiplied by every term to give me the next term. So I just wrote the geometric series in the expanded form, and A is the first term, R is the common ratio. In fact, the convergence or divergence of the geometric series depends on the common ratio. And that's how it is related to I write a note here. We have two possibilities. If the common ratio R is between -1 and 1 is strictly more than -1 and strictly less than 1. Like 1/2, like 2/3, like -2/3. So any number more than -1 and less than 1, then the geometric series converges to this number to A, the first term, over 1 minus R. If R is not in that interval, otherwise, the geometric series is divergent. Otherwise, the geometric series is divergent. Now let's see some examples. Let's look at this geometric series. We can give it in the expanded form. So consider this geometric series. Three plus 3/2 plus 3/4 plus 3/8 plus dot dot dot. It is geometric. There is a common ratio. And what is that common ratio here? Obviously, it is 1/2. So does the series converge? Yes or no? The common ratio R is 1/2, and we know that 1/2 is between -1 and 1. Therefore, the answer is yes. This is the reason that the answer is yes. So now we know it is convergent. What number does it converge to? Do you remember that formula? The first term divided by 1 minus R. So the first term here is, the first term is 3, the first term of this series, and over 1 minus R. R is 1/2. So again, as a reminder, A, the first term, over 1 minus the common ratio, 3/1 minus 1/2. 1 minus 1/2 is 1/2, and 3 divided by 1/2 equals 6. So the answer is 6. Let's see an example of a geometric series that, so all the examples from now on that we see today, just today, in future we talk about other kinds of series. And as you will see, most of the series are not geometric. But the examples that we do from now on today will be geometric. But of course, we'll see many series in the next lessons that are not geometric. So look at this geometric series, sigma of 1/3 to the power of k, and k runs from 0 to infinity. And please try this on your own. Which one is correct? A, the series converges to, so the series converges to this value, or it just diverges. So I want to know that about this series, which one is correct. So let's, if you want to see what the common ratio, it's obvious what the common ratio is, but let's try to expand this. This is, if I want to expand this series, 1/3 to the, okay, start from 0. 1/3 to the power of 0 is 1. 1/3 to the power of 1 is 1/3. 1/3 squared is 1/9. 1/3 cubed is 1/27. So on and so forth. The common ratio is 1/3. R is 1/3. And you know that 1/3 is between -1 and 1. So we have this. And also, so this tells us that it is convergent. So A is the correct answer. And the sum is gonna be A over 1 minus R. The first term is what? 1 over 1 minus 1/3. 1 minus 1/3 is 2/3, and 1 divided by 2/3 is 3/2. So this is 3/2. Okay, let's see another example. The series 5/4 to the power of n, and n runs from 0 to infinity. Which one do you think is correct? So for this series, is it A that converges to a number, or is it B, diverges? So which one is correct? Can you see what is the common ratio? Or if you would like, you can expand a little bit for this series. So when n is 0, 5/4 to the power of 0 is 1. When n is 1, it is 5/4. When n is 2, it is 25/16, or just 5 squared over 4 squared. When n is 3, 5 cubed over 4 cubed, and so on and so forth. Obviously, the common ratio is 5/4. Is 5/4 between -1 and 1? Obviously, it's not. It doesn't fall in this interval. Therefore, we can immediately say that the series is a divergent series. That sum is not going to be a finite number. Let's see another example. Be careful in the next example. The common ratio is a negative number. Suppose I'm dealing with this geometric series. K rounds from 0 to infinity, -3/4 to the power of k. So which one is correct? A, the series converges to a specific number, or it just diverges. To make it more clear, you can list a few terms of the series. When k is 0, minus 3/4 to the power of 0 is 1. When k is 1, it is minus 3/4. When k is 2, minus 1 squared is positives, and it's going to be 3 squared over 4 squared. When k is 3, that negative to the power of 3 becomes again negative. And then we have 3 cubed over 4 cubed. So it's an alternating series going back and forth between positive and negative. For this geometric series, what is the common ratio? R is minus 3/4. Is minus 3/4 between -1 and 1? Yes, it is. So then based on this, we can use the formula of A over 1 minus R because it's convergent. So we need to know what converges to what. A is the first term is 1. 1 minus R is what? Minus 3/4. In the denominator, 1 minus negative 3/4 is 1 plus 3/4, which is 7/4. And 1 over 7/4 is going to be 4 over 7. So first of all, A is the correct answer, and it is 4 over 7. Let's do another example of a geometric series. Sigma of 2 to the power of minus 3. Let me use a different letter here, J. And J runs from 1 to infinity. And which one is correct? The series converges to a finite number. If so, what is that finite number? Or the series diverges. The series or the series diverges. Which one is the correct answer? Converges or diverges? So let's expand a little bit, the first few terms to see what the common ratio is. When j is 1, j starts from 1, 2 to the power of minus 3. When j is 2, 2 to the power of minus 3 times 2 is minus 6. When j is 3, 2 to the power of minus 3 times 3, minus 9, and so on and so forth. As you know, the first term means 1 over 2 cubed. 2 to the power of minus 6 means 1 over 2 to the power of 6. And 2 to the power of minus 9 is 1 over 2 to the power of 9. Can you see what the common ratio is? The common ratio obviously is 1 over 2 to the power of 3. Because 2 to the power 1 over 2 to the power of 3 is multiplied by every term to give me the next term. And this is 1 over 8. Obviously, 1 over 8 is between minus 1 and 1, so the series is convergent. The geometric series is convergent. It converges to what? The first term over 1 minus r. What is the first term? The first term of this series is 2 to the power of minus 3 or 1 over 2 cubed or 1 over 8. So the first term is 1 over 8. 1 minus r is also 1 over 8. 1 over 8 divided by 1 minus 1 over 8. 1 minus 1 over 8 in the denominator is 7 over 8. 1 over 8 divided by 7 over 8 is just 1 over 7. So the final answer here is 1 over 7. So first of all, this converges and converges to 1 over 7. Let's see another example of a geometric series. As usual, I recommend that you pause the video and try it on your own. E to the power of minus 5n is that famous irrational number. And n runs from 0 to infinity. So which one is correct about this series? A, it converges to a specific finite value, or it diverges. So to see that what is the common ratio for this geometric series, let's see what are the terms. When n is 0, e to the power of 0 is 1. So the first term is 1, then plus. When is 1, e to the power of minus 5. And e to the power of minus 5 is the same as what? 1 over e to the power of 5, right? When n is 2, e to the power of minus 10, and e to the power of minus 10 is 1 over e to the power of 10. If I do the next one, when n is 3, it's going to be e to the power of minus 15, and which is the same as 1 over e to the power of 15, and so on and so forth. What is the common ratio here? The common ratio is obviously 1 over e to the power of 5. That's the number when multiplied by every term gives me the next term. So the sum or the value of the series is the first term over 1 minus r. A is, the first term is 1. 1 minus 1 over e to the power of 5. So we simplify this using algebra, basic algebra. 1 minus 1 over e to the 5 is e to the 5 here, e to the 5 minus 1, and as a simple fraction, it's going to be e to the 5 over e to the 5 minus 1. Since the question doesn't say that we should round to whatever decimal places, we need to keep the exact value. And as an exact value, this cannot be simplified more. So this is the value that it converges to e to the 5 over e to the 5 minus 1.